Yo, what's up, geometry students? Mr. Messer coming at you. Unit 2, we start talking about some numbers with our lengths. Like, how long is this line segment, essentially? Like, what are some characteristics of this line segment so we can kind of figure out, lengths. And we're going to start, like, applying numbers. Now, in the past, we just had this blank space, and we could copy things down. But if I asked you, like, to draw something of a length 1, it's like everybody's 1 is different. So in comes the idea of a grid system. And this grid system helps us understand, how far distances are. Now, like, if I didn't have this grid system, maybe I could decide, okay, guys, this is a length of 1 from here to here. This is a length of 1. But then, how do I know which direction to go in for the lengths of 1? These are all lengths 1. The easiest kind of ways to repeat these lengths of 1 is to just be going in straight lines to the side horizontally and up and down vertically. And this is why when we use this grid system, we don't see diagonal lines of 1s. We're going to just see a bunch of vertical 1s and horizontal 1s. Like here, this is 1 length up. This is another 1 length up. This is another 1 length up, length up. And then we could talk about going to the side, 1, 1, 1. And now we have numbers associated with this line. We can see how far this line goes up. From 1 up to 5, I'm going up 4 versus going over. I go over 2. We call this like the pitch of the line. In other countries, they call it the gradient of the line, or it's like a slope. Okay, like pitch, slope. Slope is, not a diagonal distance, but rather, if we're just talking about horizontal and vertical, this line is like going up 4 y's as we go over 2 x's. If you remember from previous math classes, we like to go up to add y's, to the right to add x's. Like horizontal, we're going to call x's, vertical, we're going to call y's. It's just easy ways to say vertical and horizontal. And then if we go to the left, we'll be subtracting x's. If we go down, we'll be subtracting. So we see that this slope, and we'll use the letter m, is 2. It's great. Now, like if I asked you, what is the length of this line? We realize it's going to be a lot more complicated than just like 2. Like we could calculate the length of this line by like attaching a circle to it. And then all of a sudden we could see, okay, look at this length here. This length here would be the same length as this diagonal line, but man, what is that? It's not 4.5. It's some other number. So like finding this diagonal length is a lot harder than we think it is. But we will use the idea of this slope. We'll use the idea of like y distances and x distances to help us. Okay, great. Now, let's make a construction that we've made before. Let's kind of pay attention to certain characteristics of lines when we associate these y distances and x distances to it. Let's create a perpendicular bisector, which I can do by just creating a rhombus. Here's my rhombus from here to here, from here to here, here to here, here to here. All of those sides are equal. I can connect this point with this point, and I create this rhombus. And I can see we have certain points that are on like very nice whole numbers for x's and y's, like horizontal and vertical locations. And I can see at a point here, that's a point there. I can see this line, we go down 1 over 2. So this line slope, I go down 1 as I go to the right 2. Since I'm going down 1, I'd call that y change -1. Go to the right 2, I call that x change right 2. And I just noticed that perpendicular lines have opposite reciprocal slopes when we attach these numerical values to it. It's a really cool thing. Cool, good start. What else do we need to know? We need to know about equations of lines. Now, this might be review for you, and you might be like, oh, I get this. But the way I like to try to explain it is like we can start from a number when x is 0. So I'm going to start with the y value of 1 when x is 0. Every time I add an x, I need to add 2 y's. So if I add 1x, I need to go up 2 y's. If I add another x, I need to go up 2 y's. I'm going to use my slope, and I'm going to say every time you add an x, you need to apply that slope. And all of a sudden, we have an equation, and I wish we could go into it more, but we really don't have the time, where it's like if you can plug in any x value, it doesn't have to be the whole numbers, it could be like decimals, apply this pitch, this slope, add 1 to it, you'll get the exact y coordinate. Cool. We'll just leave it there. Now, what if you don't know the y-intercept? We could take a guess. We could maybe figure it out. But there's another version of a line that we know. That's called a point slope version, which says, and this actually comes from your slope formula. If you remember your slope formula, you could multiply by x2 minus x1, and you have this equation where all you need is a point and a slope, and you have an equation. So here is a point. We say the x is -1, the y is 4. So the y is 4. The x we're going to use is -1. We're not going to change y and x, or else we won't really have an equation. We're going to keep it. This is like the x's and the y's based on this point, and I found the slope was -0.5. Now we can then solve this equation for y to find the location of the slope. We did this in class. If you distribute, you get y minus 4 equals -1/2 x minus 1/2. We add 4, we get -1/2 x plus 3.5. 8/2 minus 1/2 is 7/2. You need to be able to work with fractions, or we realize, 3.5. Anyways, that's like the intro. Perpendicular lines, opposite reciprocal slopes. We are applying numbers to our things that we created. We realize if we calculate some characteristics of it, like how much our y's change, our x changes, our vertical distance, our horizontal distances, we notice that there are these numerical characteristics of lines, of perpendicular lines. Boom, we remember how to create an equation of a line. Even you don't really understand why it works, we'll get into it more. That's the first lesson. All right, so here we go. Create a perpendicular bisector. Easy. I'm going to grab my compass. I'm going to extend out to A. You do not have to extend to A, but I'm going to, because I'm just going to create a rhombus, flip, with equal side lengths that are passing through A and B. And I have this point here. I have that point there. And if I connect these 2 points with a straight line, we'll make it red. I have that line there. What is the slope of AB? I can see that I'm going up 2 y's, 3 y's as I go over 2 x's. This is a great one. My y's are going up 3 as I'm going over 2 x's. We would consider this a positive 3/2 slope, or like you're going up 3 y's over 2 x's, or you're going up 1.5 y's per 1 x. You can either have this as up 3 y's over 2 x's, or up 3.5 y's over 1 x. That's what I teach my calculus students. Okay, now I'm going to take a guess, because I kind of saw the characteristics in class, because I did that exploration earlier, that this perpendicular slope, this red line slope, which is an opposite reciprocal, is going to be -2/3. That means I'm going to go down 2 y's as I go over 3 x's, or I'm going to go down 2/3 of a y per x. I will go down, let's see, let's find some points. I mean, I got this point. Oh, it looks like that's a point right there. I will go down 1, 2 y's as I go over 1, 2, 3 x's. There we go. Down 2, right 3. Here, if I go up to left 3, I should be at that. This line is not perfect. Let me just adjust it so it's really right at that location and really right at this location. And things should snap. Yeah, there we go. Right there, right there. I can see that opposite reciprocal slope. Great. So we did that. Slope of AB we found was 3/2. Slope of the perpendicular, I'll use this sign for perpendicular. It's just like an upside down capital T, stands for perpendicular, is -2/3. What is the equation of the line AB? Well, it's like we started with a y coordinate of 2 and x is 0. As I add an x, I'm adding 3/2 of a y. I'm adding 1.5 y. We have this slope times the x's that we're adding. Y equals mx plus b is just something that students remember, even if they don't understand, and it won't hurt. What's the equation of the perpendicular bisector? Well, the perpendicular bisector, I wasn't exactly sure where it passed through. Like, this is a question mark to me. We can't assume it is at a 0.5. It ends up not being at a 0.5. So when I don't have an obvious y value when x is 0, I can just use a point that I do know. I have this point 2, 1, and I can use the slope, and I'll use it in point slope form. Y minus y1 equals m times x minus x1. The m was -2/3. I have the point 2, 1. I have the slope of -2/3. So I will keep x, so I have the equation. I will keep y, so I have the equation. I'll change y1 and x1. This is fine. If we'd like to discover the actual location of the y-intercept, we can actually do some math and solve for y, and we'll turn this equation into y equals mx plus b form, something you did a lot in algebra. I will add 1. Adding 1 is like adding 3/3. If you add 3/3 to 2/3, you get 5/3. So we just discovered that that location is like 1 2/3. I made a mistake. 2, 1. I could tell it's not 1 2/3. It looks like it's 2 1/3. This is a 2. What is 2/3 times -2? We have to remember for fractions, you multiply straight across. This will be 4/3. What is 4/3 plus 1? 4/3 plus 1 is the same as 4/3 plus 3/3. 4/3 plus 3/3 is 7/3. That is 2 1/3, and that makes sense looking at my graph. 2 1/3. Don't assume you know. Don't use y equals mx plus b unless you're certain about your y equals mx plus b. Over here, it's an interesting situation. My slope is 0. What do you mean my slope is 0? Well, I don't go up or down at all. I just go to the right. I go to the right one. I go to the right one. So if our slope is how my y's are changing per x, I mean, it actually doesn't have to be. We could flip it so it's like how are my x is changing per y, but then things get different with everything that we've known and we've learned, but like we're learning things a specific way because just that's how they're done. I digress. My slope is a rise of 0. My run of 1. This is the pitch of my line. It's flat. It's not going up. It's not going down. It's flat. If I Don't love this example. But if I did my perpendicular bisector, it's pretty easy to kind of see. It's going to be a vertical line that will pass through the midpoint. But and this is the point. This is the point. This is the line. Which straightens out and then it goes right here. Now it looks like it's going to be at 1.5, maybe. But who knows? That's exactly right. We have to do the math. What we do notice that it's vertical. What does it mean for a slope to be vertical? Well, my slope is going up now, but it's not going over. Now, you might say it's an opposite reciprocal, so it needs to be negative 1 over 0. Well, like negative 1 over 0, 0 over 1 over 0, both are something that we cannot do. It's called undefined. You're not allowed to divide by 0. This is something a lot of students don't understand. They try to memorize, but the question is like, how many times does 2 go into 8? 2, 4, 6, 8. It's not your phone, is it? All right, good. Then the question is, how many times does 0 go into 8? Like 2 times 4 is 8. 0 times what is 8? This can't be done. Like, it's impossible. So you're not allowed to divide by 0, so we say the slope is undefined. Okay. What is the equation of this line? The equation of this line is y equals 2. Why? Because it's like y equals no slopes of x, no increases of x per y, plus a y of 2. What's the equation of this line? Well, like if this is at negative 2 and this is at 5, what is in the middle of negative 2 and 5? We will talk about how we can find the middle of things very easily just by finding the average of two things. And we see that, yep, it's at 1.5. So I was correct. Yeah, don't love it because I don't like dealing with horizontals and verticals, but this is reminder. Reminder, we're good. We should know this. Zero slope, horizontal line, undefined slope, vertical. What is the equation of y of the AB? 0x plus 2. You can see the y-intercept. What is the equation of the other one? Well, you have like an undefined slope. The easiest way for me to say this is like no matter what happens, my x values at all of these points are always 1.5. Here, this point, 1.5, 5, 1.5, 4, 1.5, 3. It is an x equals line. Okay. Okay. I think for this part B, they want you to construct it because we haven't talked about how we can find the middle of 2 points yet. So I'm going to go ahead and break out my guy and construct it. I'm actually going to do it in Desmos because it was fun. -5, 6, and 4, -3. So go away and watch what we can do in Desmos. We can kind of delete everything and say, let's get a new point, -5, 6, and 4, -3. Here, I'll graph it. -5, 6, 4, -3. Let me actually pause and ask a question, and then I'll come back. All right. You know what? I'm not gonna graph it perfectly. I'm just gonna like eyeball, and like I'm not gonna assume that my line is straight or anything. Like I use a straight edge, but who knows? How can I determine the slope? Maybe instead of visually, but by using these points. Well, I can see like 6 to -3. How do you travel from 6 to -3? From 6 to -3, I go down 6 and down 3 more. That is going to be a total of down 9. How could you calculate that value of -9 by doing something using a math operation? You could subtract the two numbers. Subtracting two numbers finds the distance between the two numbers. Imagine like 5 and 2. 5 minus 2 is 3. Well, 1, 2, 3 would be the distance between. This is the idea of y2 minus y1 is like the y distance between two values. What about my x distance? Well, I go from -5 to 4. I go to the right 5, I go to the right 4 more. I go to the right 1. So I go to the right 9. So this is 9. Now, how could I calculate that using my values? I could say I ended at 4, I started at -5, subtract the two numbers, you can find a distance. 4 minus -5. This is x2 minus x1. Hopefully we're starting to understand things. Now, let's find the equation of this line. We have a point, I have an ugly line. I'm going to find the equation by using point slope. I'm going to do y minus y1 equals an m times x minus x1. I have my m should be -1. What did I do? I started at 6. This should be -9. So there's a classic error. Like it's better if honestly I looked, I said I went down. So this is negative. So x minus, let's use this x coordinate 4. Let's use this y coordinate -3. So that's y minus -3, which is y plus +3. Let's distribute and solve. I got -1x plus 4. And I'm going to subtract 3, and I get y equals -1x plus 1. All right, so this is actually at 1, kind of what I suspected. Now, what if I perpendicular bisect? Could you do this without a compass? One thing you for sure know. One thing I for sure know. I know the slope is 1. If you take -1 and flip it and take the opposite of it, you'll get +1. Okay, so I know the slope is 1. But I want to bisect it. Now, what does it mean to bisect? It's going to cut in half. I need to somehow find the middle of these 2 points. This is kind of introducing what we're going to be doing later, more formally, finding midpoints. But you can kind of see it's like, well, my x's go from -5 to 4. What's in the middle of those two numbers? Well, it's not 0. It's not this point here. It's gonna have to be -0.5. How can I figure that out? You can actually find the average, -5 plus 4 divided by 2, or you can just kind of visualize. Like I go over 4.5, I go over 1, 2, 3, 4.5, I go over a half, 1, 2, 3, 4, 4.5, 4.5. So all of a sudden, I have this point which is -0.5 for my x. Now let's find the middle of my y's. Well, my y's are at 6 and -3. What is in the middle of the number 6 and -3? Well, it's like, I don't know. What we can find is we can like find the average of them. Like you can kind of guess, like, does it look like it's going to be 2? Maybe it's around 2. But watch this. 6 plus -3 divided by 2. That's 3 over 2. It's actually 1.5. So this point right here, which is a point negative a half, 3/2, that is a point in the middle where the slope is going to be 1. Where is it going to cross? I don't know. Don't worry about it. Let's just finish it off in point slope. I'm sure this is very confusing to a lot of you because we didn't really talk about midpoints in class, but maybe we'll try to get there. So we want parallel to EF, but we want through the point 3, -2. Well, parallel lines, we talked in class about parallel lines equal slopes. The slope is -1. Here's a point, y minus y1 equals an m, x minus x1, y minus -2 equals mx minus 3. So that's y plus 2 equals -1, x minus 3. We are okay if you leave it like this. If for some reason I asked you what would be the y-intercept, you can find the y-intercept by distributing. And you get that. Oh. That's funny. The parallel line is the same as the line. So they're like on top of each other. So what do we call it when the lines are on top of each other? No, that's when they intersect. There's a word.
Oh, what? Dependent system?
Yeah, something like that.
Dependent.
It's a dependent system. One thing on top of the other. Something like that. I don't think.
That's good.
Yeah. Okay. Okay. AC, this segment, compared to BD. Are they perpendicular to each other or parallel to each other? That's the question. Well, the slope of AC, either using the slope formula by finding the y2 minus y1, which is the distance between your y's and direction. I go down 6, or just like figuring out. I go over 4. I can divide the top and bottom by 2 to do down 3 over 2. Okay. And let's do the slope of BD. BD, I can see these 2 points are a part of it. I go up 1 over 2. Never mind, that's over 3. That's -2. I go up 1 over 2. What do you know about these slopes? They are opposite reciprocals of each other. If they are opposite reciprocals of each other, they are perpendicular to each other. Okay? Don't worry about proofs. Just be like, yeah, I calculated the slopes. The slopes are opposite reciprocals. What about AB and BC? AB, BC. Ooh, looks like it could be. I mean, you can kind of eyeball it and see that it's not. The slope of AB is up 1, 2, 3 over 1. It's like just talking about vertical and horizontal distances because they're easy to visualize versus diagonal distances. This is down 1, 2, 3 over 1, 2, 3, 4. So the slope of BC is down 3 over 4. Are these opposite reciprocals of each other? No. Are they the same as each other? No. We'd say it's a neither. It's not parallel, it's not perpendicular. Okay. Oh, cool. Just like a little slope question. What is the slope of this graph marked to the right? Many of you are probably thinking, oh, the slope is down 1, 2, 3, 4, 5. I go down 5 as I go over 1, 2, 3, 4, 5, 6, 7, 8. So this is down 5 over 8. But they're saying, what if the X tick marks are 2 units? What if this is kind of like scrunched a little bit? It's not like a 1 up is not the same as a 1 over. We can change things very easily so that it's not scaled the way you think it should be. For example, let me just go to the calculator because I can change my axes a lot easier. I can say, let's go from -10 to 40. Now, if I did not have the numbers, boom, you would probably think this is 1, 2, 3, 4, and this is 1, 2, 3, because they're like looking like equal distances. But that's not the case. This is up 2, 2, 2. This is over 5, 5, 5, 5. So everything doesn't have to go in once. Okay? We might not be necessarily counting just like 1, 2, 3, 4, 5. It could be 2, 4, 6, 8 as you go over 5, 10, 15, 20. Okay. If I go down 5 and every tick mark is 1 unit, I'm still going down 5. If I'm going over 8, but every tick mark is 2 units, I'm going to be going over a total of 2, 4, 8, 10, 12, 13, 16. 8 times 2, 16. So very interesting. I'm still going down 5, but now, like we shrunk it. If we stretched it out, it would be a shallower slope, a less steep line. What if this was not 1, but 100? Well, we'd be going over 800. What if this wasn't just 1, 2, 3, 4, 5, but rather 5, 10, 15, 20, 25. 5 times 5, 25. We'd get that. Just interesting thought processes, not designed to trick you or be tricky. Just more like, all right, cool. Yeah, if there's probably problems with you guys that I'm worried about is like, do you really know how to write an equation of a line in point slope, in slope intercept? Do you know how to take slope intercept and turn it into point slope? You have to have that stuff down. Perpendicular lines, opposite reciprocal slopes. Boom, we visualized it. Parallel lines, equal slopes. That's it. Good luck out there. Peace.